today we have a fantastic guest, Charles Conwell, the CEO of Novele.
We've maximized the output that software could have in our analog world. So at the same time, we're rebuilding the hardware infrastructure.
What they do is Novele is an energy technology company that transforms buildings and data centers into intelligent energy assets.
When you're bringing new technology to a market, especially if it's climate tech or sustainability, it has to be accretive economically to your customers.
Charles actually started his career in real estate and then chose to move into the CEO role at Novele.
I think my role is to find the problem and then find people who agree that that's the problem and they want to help do it.
When you start bringing intelligent infrastructure and storage into buildings, distributed throughout buildings, you're going to see innovation in energy generation within those environments.
Hey everyone, welcome back to the Clean Techies podcast. I'm Silas Maynor, your favorite clean tech headhunter. All right, today we have a fantastic guest, Charles Conwell, the CEO of Novele. What they do is Novele is an energy technology company that transforms buildings and data centers into intelligent energy assets using their 2-inch thin energy storage product that can fit into buildings without really cutting into the leasable space. This is specifically in the commercial application. So it's a hardware plus a software asset sold as a hardware as a service. Think these very thin batteries that kind of get tucked into the different parts that are of the building that make sense without taking up a lot of space to give it this kind of flexibility of a building as an asset. But it's very small and it works specifically for the commercial real estate sector. So why I'm excited to have Charles on is that Charles actually started his career in real estate and then chose to move into the CEO role at Novele. And for this reason, I think it's super exciting that we get to see somebody who comes from the industry of real estate and knows how it works, etc. They were able to move into this electrification space. So we ended up spending some time asking him what he saw in the space that made him realize it was worth the leap. Then we covered their technology and how it works. He also uncovered why it's taking so long to get commercial real estate owners to electrify. It might surprise you, actually. I won't spoil it, but it's very, very fascinating. And we had a great discussion about hiring as well. That's one of the things we ended up spending quite a lot of time on. And he explained towards the end why nuclear baseload power and energy storage actually make a great combination, despite what a lot of people usually argue against. They say, oh, we just need nuclear. We don't need storage. Well, he has a different take on it, and I think you'll like it. So before we start, a quick shout out to the sponsors who make this show possible. First, we have Climate Finance Solutions, your first call whenever you're looking to apply for grant funding. They have helped clean tech startups raise $1.6 billion since 2020 and have a 90% success rate at winning the funds they apply for. So they're very good. Reach out to them. Secondly, my company, EarthSearch. We're a full-service recruitment firm helping clean tech startups build and implement differentiated talent attraction systems that will give you an unfair advantage over your competitors. Reach out to learn how we do that. And finally, do not forget to register for the upcoming Hack Summit at New Lab in New York City. This is happening December 10th and 11th. There will be about 500 founders, investors, and ecosystem supporters in the climate deep tech space specifically. And several of our past podcast guests are going to be there as well. So that's why we're going. We're going to create content for the event. It's going to be a lot of fun, a lot of really amazing people there. The link to register is found in the description. All right, without any further delay, enjoy the episode. All right, Charles, welcome to the podcast. How you doing?
I'm doing well. How are you? Happy Monday.
Yeah, happy Monday. We're recording this on a Monday. Obviously, this should come out on a Wednesday. Usually that's when it happens. But that's all right. No, it's a good Monday, even though it did snow here in Wisconsin yesterday, though. So I'm not exactly thrilled about that, although my brother is.
We're about to enter a polar vortex in New York, so
well, good luck with that.
We're all experiencing the cold.
Yeah, I'll be in New York very soon. We're going to be spending Christmas there. But yeah, I guess for anybody who's unfamiliar with who you are, give us just a little bit of a background on who you are and what you're doing at Novele.
So I'm Charles Conwell. I'm the CEO of Novele. And Novele is an energy technology company that's transforming buildings and data centers into intelligent energy assets through our AI-driven hardware and software.
Got it. We'll get into a little bit more about what that means. Obviously, I have the background context, but one thing I want to ask before we get too deep into it is, if you could time travel into the future, let's say 10 years, and see how climate tech has transformed urban energy specifically, what would you be most excited to find?
For me, I think that we'll see our systems and our infrastructure functions at a much higher level of quality. There'll be incredible qualitative improvements in how we move around, how we experience, suburban and urban areas from, and sometimes people think, I think typically about climate tech, just about sustainability from a pollution standpoint, but there's a lot of things in our world today that are noisy or smelly and that affect our experience. And I think we'll see lots of improvements in not just how those things make us feel, but the efficiency and when it overlays with some of the AI insights that we'll have, how readily available and ready and prepared things work, how well they work.
Hmm. Do you think that's because people are just going to start focusing on these new problems to solve, or like is there some kind of paradigm shift that's going to allow this to happen? Like, what is the main reason that will take place?
So I'm a believer that in the iteration of the revolutions, the technology revolution, how things have happened, it sort of started first with computers and software, and we really got to the point where we've maximized the output that software could have in our analog world. And at the same time, we're rebuilding the hardware infrastructure that's now designed and developed to integrate much more seamlessly with software and controls. And so that's when we think about like robotics and all of the intelligent function. But the fact that this is happening at the same time with AI, machine learning, these devices are much more sophisticated, and I think the outcomes that we'll expect are all kind of coming together at the same time. So they become more efficient, the productivity is higher, but the experience from a qualitative standpoint is much improved.
It's very interesting to consider. I like this thought. I've never thought about this before, but when we saw the first industrial revolution, it was really solving kind of just general, like we're going to make life better, right? We're not going to have to be doing everything by hand, like make life easier for a lot of people, and just build these what are now effectively luxuries to us, or we don't think they're luxuries anymore because they're so common. But now that we have this kind of baseline situation, as we're building new technologies, we consider other things like circularity, sustainability, noise pollution, all these things that we never considered because before there was no issue, right? We didn't consider like, oh, that's like such a negative thing. And now we can see these. So it's very fascinating that we can, if we focus on the right things as we're going through this new revolution, it'll be a better outcome. I like that a lot. I appreciate you bringing that up. That's a unique thought. So let's talk about the technology a little bit more. So you mentioned that you guys are helping commercial buildings and data centers turn to, I forget how exactly you worded it, to basically use their energy better. So can you tell a little bit more about the technology? Like break it down for us very simply, as if we don't know anything about the industry.
So Novele has three products, essentially. One called the Energy Board, Board OS, which is our software operating layer, and then something called the Ripple Board. And the products work in collaboration with each other. But really, if I start with the Energy Board, when we think about this energy transition that's happening, when we started Novele, we set out to solve a problem as if we were redeveloping the grid today with the technology and insights available. And our focus is at the point of energy consumption. How do we consume electrons? What happens if we're able to build a network and infrastructure that can learn how we consume power and then reshape those demand curves? Because energy demand is always variable. But if you're able to reshape it, flatten it, you can effectively predict how we utilize power and make and use that data to supply our grid generation, our infrastructure. So it becomes a proactive, predictive way to consume and produce and consume power versus the reactive system that we have today. And so the Energy Board is a energy storage device. It's a battery that goes throughout buildings. It's distributed throughout a building. And then our software architecture, swarm architecture, allows us to orchestrate hundreds of devices, reshape demand loads in real time, and then use those data insight to help build a more efficient grid.
Mhm. So,
reducing costs in buildings and for building owners and occupants.
and so this is going to be behind the meter. So the batteries get installed in this building, and then it's going to understand, hey, we've got high demand coming from the grid, so we're going to switch to our own battery power to reduce the load on the grid and use it for our own building, not selling it back to the grid, correct?
Yeah, not selling it back to the grid. You're really utilizing and optimizing the capacity of that variable load in the building, and there's huge economic benefits to the occupants and owners of the building and to the grid. So it's a full alignment of all the stakeholders
Hmm.
involved.
What are the core benefits aside from cost of energy?
So when you think about just the energy savings, I think when you're bringing new technology to a market, especially if it's climate tech or sustainability, you have to have an economic. It has to be accretive economically
Yeah.
to your customers. So that's critical. But beyond that, building owners, occupants around the country are facing new local laws that they have to comply with. Obviously, the energy pricing resiliency is really, really critical. And I think all of those parts of the stack around energy are really valuable to our customers. And then obviously, the insights and the data we generate become really valuable, and the controls to how you think about how that building will utilize that electricity, over the next decade and beyond.
This episode is brought to you by Climate Finance Solutions, the firm helping climate tech companies win the major government grants that drive their scale and impact. Since 2020, they've won over $1.6 billion in public funding for their clients, with a 90% success rate on the dollars that they've applied for. Their team has also helped win more than 500 million euros in European funding and managed over $275 million in grant projects. With a global team of 27 experts, CFS supports climate innovators through every stage of the funding lifecycle, from strategy to proposals to project execution. They also have a grant identification platform that enables real-time monitoring and custom matching of opportunities with alerts as new grants are released. If you're a climate investor, accelerator, or ecosystem builder, you can even join their partnership program to unlock pro bono support for your portfolio companies. Learn more at climatefinancesolutions.com. All right, back to the show. Mm-hmm. Do you have any numbers specifically as to what you're seeing your customers typically save from an energy cost perspective? And could you just help us understand the cost of the system and then what they, likely expect to get as a return on their investment?
So, the system is a modular, scalable system. So we're able to size the system for our customers based on how much energy they're consuming, and we're able to retrofit certain buildings over time if they're multi-tenant kind of use spaces. So the pricing and system size is really customized. So that's one part of the process that I think our customers really, really like. In the markets that we're starting to deploy our product in, to pretty much on the coasts in California, in New York, Connecticut, Massachusetts, the energy bills are typically broken into two parts: the capacity and the demand and the transmission of the energy, and then also the consumption, so the actual energy you're consuming. The demand charges are exceeding at this point the actual cost of the energy itself, and so for our customers, we're able to save 10, 20, 35% of their energy bill, generating really significant IRRs for their buildings, mid 20s, 30% and above in some cases, just focusing on those demand outcomes today.
Got it. And so demand charge is when they're pulling power at a time where there's like high demand, so they're basically putting an extra cost on top of it to try to incentivize people to go off. Is that correct?
It's your demand charge in your bill is the highest. Typically it's the highest 15-minute increment in a month that you consume power, and so it's essentially an allocation of power that the utility provides to you because they need to have that peak load available to be turned on and utilized by you. And so the goal is to really make your building more efficient, make that load factor, 95, 98%. Typically in commercial buildings, it's anywhere from 30 to 40%. And so you've got generation essentially on the sidelines waiting to turn on, be reactive to the power that you need, and the utility charges you for that capacity that's not being used most of the time.
Got it. Now, I'm very curious, why not use other technology? Why specifically use what you guys have built? Is there specific nuances as to the way it goes into the buildings, the scalability of it? Like, how come not use a power wall, for example?
So I think what's really, really critical for people to understand is that when we look at buildings, we have, first of all, safety is critical, right? In the battery industry, there has been some incidents and there's some misinformation about safety, but driving and building the safest systems to go into buildings is really, really critical. Additionally, there's lots of distribution. The way these buildings are built, the distribution is spread out. So having a distributed system becomes really valuable to understanding how we consume energy and then predicting it. And the key is to have that software layer that can orchestrate, hundreds of devices and allow those to work in coordination so that you can get, megawatts potentially of stored capacity within the building, but operating independently and together as they may be needed throughout the useful life of these systems. The other part of it, Silas, is you really need to think about how the space is used and what the product that landlords are selling, which is that physical space. And so you can't just take up that footprint. That needs to be, that's a usable space. Yeah. And the installation of that can be quite difficult. So, by building something that's modular and that's infinitely scalable allows us to, continue to optimize the size of the system over time. Easy, quick installation. Mm-hmm. Obviously, I said safety is really critical, but being wall mounted and 2 inches thin creates not only there's no problem from the installation standpoint. There's no loss of usable space or impact to your potential NOI because you're sacrificing that footprint for storage.
Yeah. Now, who are the main customers that you guys have ended up finding are really demanding this product right now? I think you mentioned two specifically at the beginning.
Yeah, so we've been working with some large enterprise retailers, commercial office and industrial landlords as well. We're starting to collaborate and work with some buildings in the healthcare space, but any commercial building that has industrial manufacturing that have these uses a pretty significant amount of power has a great opportunity to benefit from systems like this.
Mm-hmm. Got it. So there's a lot of use cases hypothetically is what you're saying, but you found probably, it sounds as though the hospital one I can imagine is really like they absolutely need power. They need to have these backups. They're also consuming power so they can save money. Even if the power is not going out, they can still save money on that. And the same thing basically applies to all these other. Can you talk about the data center piece a bit? You mentioned that at the beginning. Curious to see what you're seeing there.
So the Ripple board is a product that we built for data centers, and that's a rack level power conditioning unit that provides demand controls at the point of the consumption. And the way we've seen server racks and data centers with the NVIDIA GPUs, going to the Blackwells and then the Rubins coming up next, the amount of power they're consuming and the speed in which they're iterating is creating grid issues, interconnection problems for data center developers. Data centers, inference and training workloads typically synchronize and create, variable demand loads in these data centers. And the issue that's really coming out of this problem is that the cost to bring that interconnection or create that generation that meets the peak load requirements of data centers is such that you need to have or an abundance of consumption to return that investment to the developers of the generation. So the utilities, just for the sake of the conversation. What's happening though is there's actually a significantly lower amount of power being actually consumed by those data centers. And so the economics are sort of in an imbalance. And then also there's a risk of functional obsolescence from those data centers for the amount of peak power that they have. And so industrializing the power infrastructure, bringing it to the rack level becomes critical to manage and flatten those workloads and utilize power more efficiently. But additionally, we're going into a place where the amount of power and the speed in which it's being consumed is going to have to shift to 800 volt DC. So the distance in which that power moves becomes critically important. You've got a much more efficient delivery of direct current, via 800 volt DC
I see. Okay.
bus.
Yeah. Just out of curiosity, I don't know if this question may be silly because I don't know if I understand if I'm asking incorrectly, but how important do you think it is that the software? Sorry, I should back up. Do we need generalist software that can handle all of these applications, or do you think that it's going to require specialized software that understands how to learn what's going on with that particular use case to charge and discharge the batteries at the right time?
There's a lot of different schools of thought and approaches to what type of products solve these issues best. I am a believer that when you are building critical infrastructure, when software and hardware are developed together, you have a much better control of how that hardware is actually working and distributing. So electrical infrastructure is one of those categories where it's critical. I think that you have that. Additionally, without having the ability to orchestrate that power, understand, the data insights you get from learning how you consume power, modeling and understanding, the weather patterns, what the energy mix is in the ISO, and the day ahead spot markets, the occupancy of the building, and making those predictions, you have more room for error and failure in the system. And so I think it's critical that these type of products are developed together and create the ecosystem that can be then built on top of that platform. It's really that base level infrastructure platform that has to, work really well with each other, and for the communication and security as well.
Got it. Okay, that's helpful. So I want to back up a little bit. If I understand correctly, and you might have to fill me in and color this a little bit. You, prior to taking this role, you worked in commercial real estate. I don't know exactly the specific kind of focus you had, but you worked in this space, and you ended up coming to Novele. So I'm just curious. Can you tell me a little bit more about that experience and where you started to see the opportunity that led you to say, "Hey, I'm going to go into the power business effectively"?
Good question. So I spent nearly 20 years in commercial real estate, both on the West Coast in Southern California and then based in New York City. And around, 2017, there were lots of new laws around decarbonization that were starting to be talked about and, potentially going into effect. In New York City, we had something called Local Law 97 that was enacted and then went into effect, had its first requirement in 2024. Local Law 97 is a building local law about energy consumption and efficiency, and there's fines for building owners and occupants, based on how, inefficient the building might be. At the same time, we were seeing more and more, or I was seeing more and more tenants asking for load letters in buildings that were beyond what I thought they really needed, right? And so you started to see there's two things that became kind of obvious. One is, we got to make our buildings more efficient. There's not a lot of hardware that's able to do that. There's a lot of software and some devices that were giving us data, but that data required, human intervention always. And whenever there's human intervention, it can be slow to make changes, timing's off, and it just doesn't work very well. And real estate companies aren't always, incredibly good at, analyzing and making that data really actionable. And so we knew there needed to be, an intelligent layer to this, but a hardware device that gave us the power to deploy power in really intelligent ways. And also we were going to have capacity issues in these buildings because, in New York City, much of the office market is already built. There's a connection. We know the total amount of power in the building. And if every tenant starts to ask for more power, you're going to run out of power. But we also really understood that, people didn't really use the power that they were asking for, right? Because a load letter is essentially what everybody works off in the real estate industry. And that's, in a most simple description, it's an aggregation of the peak load spec from every device that you're going to have added up. And, the assumption is, here's the amount of power I need because at some point I might use all of it at once. The reality is that's not how we consume power. And this kind of goes back to what I said in the very beginning about, starting at the electron that we consume, understanding how we consume it, and then reshaping those demand curves. Because we don't use we rarely use the peak power from any of those specs to begin with, and we never use them all at the same time. And so if you bring the controls, the intelligence, and the hardware, you can really start to move around how and when you use that power without having, human intervention, adjusting thermostats, dimming lights, turning off, different pieces of equipment to respond for some of these demand response in the way that we've really been doing it.
I am super excited to share that we at Clean Techies are going to be making content at the upcoming Hack Summit in New York City. This is returning to New Lab December 10th and 11th. And here with me to tell us more about Hack Summit is Laura Hodgkiss from Climate Hack.
Thanks so much. Yeah, it's great to be here. Thank you.
Thank you so much for taking the time to just break down a little bit more about this summit. A lot of people are not familiar. So in brief, can you just tell us what is Hack Summit?
Yes, absolutely. So we're really excited. Last year we came to New York for the first time, having hosted 5 events in Switzerland. We had a fantastic success, amazing people that were joining. It was investors, founders, corporates, CVCs and operators, all within the climate deep tech space with a real enthusiasm and commitment to collaborate. And it's really a chance for everyone to come together. We want to accelerate more investment into climate deep tech, unlock those opportunities. We want more startups to be seen by investors and operators to find their next scale up partner, find new partnerships to grow, collaborations that spark at the Hack Summit, then go on to create great success.
Especially the focus on the deep tech side of things is really important because it's very difficult to move these things forward. So Climate Hack is the organization that's putting this on. Could you tell us a little bit more about Climate Hack specifically?
Yeah, definitely. So Climate Hack is a global community. The team is based in Switzerland, but we have ambassadors who work all around the world with us, and they're putting on local free events in their communities. The aim is really to bring together people that could be students, it can be investors, startups, and founders coming together. And then throughout the year, we're writing different editorial content to connect the dots between investors and startups so that more people can understand what's going on, what are these technologies, and how can they get involved in the climate tech space. And the Hack Summit is really the occasion where everyone can come together twice a year now for the Hack Summit to be able to have those exchanges and get together.
Can you tell us a little bit more about who is going to be there? Any particular names you want to mention, or generally the type of people who will show up?
Yeah, definitely. So we have a wide range of founders working across the climate deep tech space, and they're going to be joining us for fireside chats with partners from the VCs that are backing them as well to uncover their journey. So for example, we have Cody Fink, who is the co-founder and CEO of Brimstone. He's going to be joining Rachel Slaybell, who's a partner at DCVC. And then we have, for example, Liz Dennett from Endolith, and she's going to be speaking to Deborah Zajac of SOSV to talk about her scale up and growth. And then also we can learn about what's happening at SOSV. We have Sampriti Bhattacharya, who is building America's first all-electric hydrofoiling vessel. And then I'm also personally excited about Laureen Meru, who's the founder and CEO of Hertha Metals. I'm sure you probably saw as well, she recently came out of stealth with 17 million. And now she's forging the future of steel.
Yeah, there's so many really fascinating companies. What are you most excited for about Hack Summit this year particularly?
It's a really exciting moment when you enter and all of these incredible founders and these investors and these operators. It's that real energy in the room, I think, that sets it apart from other conferences. The most senior partners from the VC funds or the Series B, Series C founders are really willing to talk to the earlier stage founders or make time for everyone. And I think that's really what the climate deep tech community is. It's really, really powerful.
Who should apply to come to the Hack Summit?
So the Hack Summit is the perfect event for founders that are fundraising. It's for investors that are looking to find what's new and next that's happening in the climate deep tech space. And it's also open for CVCs that are looking to partner with startups and operators that are working in the space. If they share our passion and excitement for scaling deep tech solutions, then they should be in the room.
And where can people apply to come to the Hack Summit?
So hacksummitny.com is the website to go. We've got the sign up there.
Yeah, it was as soon as I saw that this was happening, I was like, man, I have to go because half of your main speakers have been on the podcast already. So it's a perfect fit for us. But no, I'm really excited for this, and I hope just encourage everybody, if you have the opportunity, come to this summit to learn from founders who have already scaled to a very large extent. Maybe you need to learn from somebody who's further along, or you've got some lessons to share with other founders earlier in their journey. So apply to come today. You heard it. The link will be in the description, and we hope to see you there. Got it. So generally speaking, you were working in real estate. You saw this kind of interesting trend around demand, increased requests for more energy demand, but you saw there was just kind of a disconnect between how much they were using versus how much they were asking for. And then the combination of that with the local laws giving actual penalties to it, that really led you to be interested in this space. So did I get that right, that around, like, you'd say like battery technology in buildings might be around like 2017, 2018 is when you started to recognize this?
So I would say that was around the time that Local Law 97 in New York was
Okay.
announced, right? And so it was really like 2022, 23 where we started. 2023 really was when I got involved and started to, pursue this, build the hardware, develop the team, and sort of define, where we believed we needed to attack this problem. That was in the building, as close to the point of consumption as possible.
So before Local Law 97 made, headlines and everybody started talking about it and knowing what they had to do in the future, were building owners not necessarily concerned about the extra demand charges they were getting hit with, or was it not really as much of an issue? There just wasn't, as the utilities were having an easier time delivering the power?
Well, I think, one, there wasn't stress on the grid to the extent that there is now. And so I don't know that Local Law 97 was designed to ease pressure on the grid. I think that just is a coincidence that happened as, we started to consume more electricity. Remember, in the mid 1970s, about 20% of the energy we consumed was electricity. Today, that's like 84%. And so machines that consume electricity as their power source are much more highly efficient than, combustion engines. And so we had a lot of different types of, the heat in buildings was steam heat or boilers with a mechanical system in the basement. There were, diesel equipment and mechanical engines that did elevators. So these things have all, over the last 20, 30 years, even more recently in some cases, gone to electric, right? So the building is consuming a lot more electrical power and infrastructure than they did in the past. These machines are much more efficient when they're using electrical power, but there's just more of them now doing that, right? And so so that's where the pressure from the grid is. The buildings are really just inefficient. And part of the reason that buildings are inefficient is because landlords own the buildings and tenants really reimburse and pay for the utility expense, right? But it's always been a variable expense. And there's a reason that the tenants pay for it, is because it's really what they're consuming. And so there's always been this little disconnect between the landlords and the tenants, because the landlords own the physical plant. Typically, the owner of that physical plant would be the one that's responsible for upgrading mechanical equipment, infrastructure in the building. However, because the tenants are paying those bills, generally the feeling was, if it's going to benefit the tenant and they're going to reduce their electrical spend, they should be investing in this hardware. The reason nothing really happened was the length of the leases was generally shorter than the useful life of the product, or the technology, or the hardware, or whatever, however we want to call that. And so you ended up in sort of this, environment where it sort of just worked, but the tenants were reimbursing, the landlords were paying for the utility directly.
So there was no incentive for the building owner to actually reduce operating expenses, because in this particular case, they didn't have to. Like, they were just getting reimbursed. So it was actually the tenant paying for it. But because the tenant wasn't necessarily going to be there long enough in many cases, the building was like, tough luck, like, just keep paying the electricity, right?
Well, yeah, they wouldn't do it, because, if you've got a 3-year or 5-year lease and the useful life of the product and the payback period is, 6, 7, 10 years, you wouldn't want to make that investment and then leave that new upgraded system
Interesting
to the benefit of the next tenant or the landlord.
Yeah, it's just an incentives alignment issue, right?
It's totally a misalignment of incentives. You're absolutely right.
I don't know how you would. I mean, have you seen anybody fix that incentive structure? Like, have there been unique ways that people have done this aside from the actual penalties of Local Law 97?
Well, so Local Law 97 is helping with that. Certainly, it's certainly driving some of the incentives to upgrade the building infrastructure. Also, we're starting to see tenants paying a premium rent for spaces that are more efficient. And now, with the strain on the grid, there's a concern about actually having the power needed to operate, right? So it becomes sort of, it goes from being a nice to have, like like you might hear business school people talk about it, like it goes from being like a vitamin to a painkiller, right? Like
Yeah.
it's nice to have, but now it's becoming a requirement. Like we need to make sure we have a defensive strategy around energy, and we're going to be in buildings that have, built in, resiliency and energy flexibility. And so we're seeing more and more landlords looking for to make those investments
Yeah.
today and build infrastructure that is attractive to
Mm.
their customers,
Yeah.
their tenants.
So this is kind of the critical question, right? A lot of commercial real estate, just real estate generally is like an old school type business. Like, are you saying that now the trend is that most people are accepting that kind of fate, that they have a responsibility if they're, leasing out large commercial spaces, that they're going to have to find strategies to get a little bit smarter on these things and invest in new technology? Is that broadly taking up right now, or is it
So,
still very early days?
So a couple things. I actually want to go back to the last question too, because you asked like, how are you bridging the gap for those
Yeah.
incentives? So one of the things that we do at Novell is, we obviously will sell our system to customers, but we do have a hardware as a service, right? And so it essentially eliminates that out-of-pocket expense for the landlord or the tenant to get the system installed, and then there's an operational cost to that, but it's just like a subscription fee, and then there's the savings on top of that. Generally, in those cases, the savings are far superior within the first year than any of that subscription cost. So it's a net savings, but now you don't have any of the question of who's sort of picking up the initial capex tab. With regards to the adoption and what we're seeing, I think the big shift that's happened is for 30 years, energy prices went up at 1.5% to 2% a year. It's very predictable, pretty consistent. Since 2023, in places like New York City or California, we're seeing double-digit increases per year, sometimes as high as 20%. New Jersey last year, they had a 20% increase in their electricity, and the PJM market is a 30% capacity increase in pricing. So you're seeing compounding electricity prices that people have never experienced before. And so not only are they worrying about whether or not the power is going to be available to them, they have this enormous cost that they're having to deal with, and a lot of uncertainty around that. And, flexibility, capacity, and really what we're doing when you think about building a distributed infrastructure and this swarm software architecture is a 0 point of failure resilience model. So instead of the legacy resiliency kind of being, it'll fail, but now we have an alternative means to return power on, it's let's prevent the failure or limit the failure to the most small amount of space, and then fill everything up with the controls that we have distributed, because there's no single point to kind of disrupt the system.
Clean tech startups need to hire the right talent to hit their milestones, especially in the early days. Without the right team, you'll never make it to your Series A round. And after years of observing this struggle that pre-seed and seed stage clean tech startups have to get the right talent, I decided to create Earth Tech Talent. Our mission is to help clean tech companies hire the best talent so they can succeed and make the world greener. So whether you need some advice on how to craft your talent acquisition strategy, you need to increase your number or quality of applicants, or you need help screening the candidates to save you some time, or you just need traditional headhunting services, reach out today. We have priced everything so that even a pre-seed startup can afford it. Fundamentally, you're only building on clean tech startups because you care about humans. Your hiring process should reflect that. Work with us to craft a hiring process that is human-centered. Doing this will lead to all those job applicants becoming your biggest champions in the public. And even if they get rejected, we make it so that they will still have a positive experience and they'll want to apply again in the future, and they'll be your biggest advocates. To get in touch, reach out to me on LinkedIn or go to earthtechtalent.com/contact. That's ERTH techtalent.com/contact. All right, back to the show. Yeah, that makes sense. So then I guess that plays into then, can you tell me more again about the current landscape of these building owners? Are they really diving headlong into this, or do you still think like where are we in terms of the adoption curve for commercial building owners, the owners actually doing something about this?
I think that we're still in the early days of it. There's still folks that we talk to that it's a discovery process for, and there's other sophisticated institutional owners that have been actively developing a strategy around this and looking for ways to build out, energy platforms within their portfolios. In some cases, as far as saying that, as this scales within their portfolios, they may create a separate business unit that really controls this stuff.
Mm-hmm. So then this goes back to the question I'm trying to figure out the true, like, what's really driving the adoption of the technology. Because if there is a misaligned incentive structure, is it primarily this cost savings, or is it primarily regulatory concerns, or just a combination of all these things where the tenants are asking for it and the building owners say, okay, we'll do something about it?
When we started this call, I said it always starts, the decision, the action are always based on the economics,
Mhm.
right? Leases by their nature are medium to long term, in most cases. And so there are situations that I would say where there's portfolios of buildings that an owner might have that have leases in place, and the occupants in those buildings are sort of, beholden to the terms of that existing lease. And so when we talk about adoption, the adoption is on a different timeline based on certain ownership structures and what exposures they have to different markets, right? If you have 4 buildings and you're 85% leased and 90% leased, and most of your leases have, 3 to 5 years left, you're probably less likely to do it. And you're a smaller owner operator. Those are typically not the customers that are the early adopters and the first movers into a new technology like this. However, there are, institutionally owned, private equity backed, or, insurance company backed, or pension plan backed real estate development operators and owners that have national portfolios, very sophisticated, energy and sustainability teams. They are communicating with their tenants, and they're anticipating, how to cut off and prevent these problems from affecting their portfolios prior to it becoming a problem. A little bit of like, when did Noah build the ark, right? Sort of before the storm. When you see energy prices compounding at, 7, 8, 9, 10, 12% a year, you don't have to wait for your tenants to be moving out of your
I
building
see.
to start adopting the technology.
Yeah. Okay. So there is still the incentive structure effectively. Is like, if they can, as a building owner, effectively reduce the cost that their tenants will pay for electricity because of what they're doing as the owner, that will incentivize additional leases or the retention of future leases, right? Either
Yeah,
way.
and
So it is a financial incentive.
it's being driven by financials, and a product like ours becomes really valuable because you don't need to go retrofit an entire building at the same time. So you might have a little bit of space vacant and say, hey, like, let's do it, let's install it. Does it accelerate the leasing? Do I get a premium rent? You're able to do some of that testing and see the results in real time.
I see.
Because we're not generating energy. We're not, some thermal management where we've got to see how it works throughout the summer and the winter. Like, in the first day of our system installed, we start to see the results. Within a month, you've got a good indication. Within a quarter, even better. And so, you can start to measure the success of the system quickly. And that's really helpful because you can basically develop a rollout plan throughout a portfolio, starting in the highest impact geographies with the highest impact buildings, with the space that's currently, available to be leased, or tenants who are having a problem, and then develop these scalable rollout plans throughout your portfolio.
Yeah, that makes a lot of sense. I guess I never really put that together, that they can, if they're trying to, say they've got 20% of their building left to lease, and they're trying to get some people who are more, targeting, lower energy costs, they can say, hey, we'll work with you with Novele to bring in this hardware as a service so that you can attract the new tenants. You don't have to do it for the whole building. That's
and you get a lower price, you've got control, you've got capacity, you've got resiliency built in, and now you're starting to see buildings that have these kind of technologies, getting premium rents and faster leasing velocities.
Exactly. So now I want to understand what kind of scale have you guys reached so far? How many deployments, and what are you looking at in terms of orders?
So, we just started commercializing in 2025. We will, outpace our projections by 100% this year.
Wow.
We'll, have about a megawatt, just under a megawatt of installations by the end of this year. And next year, based on our current pipeline, we expect to have, significant growth in 2026.
Nice.
Compounding,
And you said how many megawatts will you have deployed by the end of the year, likely?
of 2026.
Sorry, no, of 2025.
Oh, we'll have just under a megawatt
Okay,
of 2025.
Yeah.
2026. Go ahead.
I was going to say, which is probably actually a lot more than people think, because there's not a lot of technology that has gone through the entire process of getting UL certified to get into buildings, correct?
Correct. There's been no other systems that have done the large scale fire testing that we've completed either. So it's been a long R&D process and a lot of work and proof of, burning systems to the ground to show people how the safety on these systems.
Yeah, that's really helpful. I appreciate the insight. I think it's good to see that there's actual product going into the buildings already. I love to see this, and I'm really excited to see what will happen by the end of 2026. Just out of curiosity, I don't know if you want to speak to this. Like, what are the core bottlenecks that you guys are running into now? Is it just simply manufacturing more product to get it out the door?
So I think, the bottlenecks that exist in some cases, like we're working with the FDNY and New York City Department of Buildings to, become certified to do installations in New York City. So there is still some apprehension, I think, from, AHJs with certain technologies, given, what we've seen happen with some of the, e-mobility devices, and obviously Moss Landing was a big issue in California. But, the sector overall, I think is doing a good job. But Novell, our mission is to deliver, one of our core values is to deliver the safest product in the world, to bring, technology that adds, economic savings, resiliency benefits, sustainability outcomes for buildings, and do it in the safest way possible. And we continue to push every day to demonstrate that, so people are getting more comfortable with these types of technologies, because they can have a huge impact. They're going to be a huge force multiplier in the space, in the energy space, and for the next 2-3 decades.
Yeah, no, I think this is really cool. I appreciate you sharing some of that. I know that a lot of people talk about the workforce of some of these things, of actually getting installations done, not just in this particular industry, but all across clean tech. There's a huge shortage with at least the blue collar workforce of getting things done. So I'm curious to see that. On this topic of talent, let's talk about this a little bit. You've had a long career, before even Novell, that you've done a lot of hiring. I'm curious how you personally hire good people. Like, what is your thesis around this?
I think, this may sound a little cliche, but the best people always want to work on the hardest problems. I think that is sort of universally true. They're also the same people who, in some respects, are focused on the outcome of their hard work, and can take, for lack of a better word, the pain and suffering that comes along with solving a big problem without clarity of when or how that's going to be done.
Mm-hmm.
And so when we're hiring, we're really looking for incredibly talented engineers, salespeople, computer scientists, like the whole team, who wants to join our mission and embed themselves in our culture, which is all about teamwork, collaboration, and solving really, really hard problems, both from the software side and the hardware side, and continuing to innovate and drive how we consume energy forward.
This is a fascinating paradox, because it is very true what you said, that the best tend to want to work on the hardest challenges, because they've usually risen to where they are because they're quite good. And then obviously, if they're good, there's some sort of success associated with the company they work at. And then they get bored, right? Because they kind of now become more corporate. It just naturally happens, and they want something new. So you can attract them by going and presenting them this this sort of risky journey that they can go on, even though it's not necessarily always risky. But then you, on the other hand, the other side of this paradox, you have the issue of how can I de-risk the company to the investors, and like, how can I do all these things that make it more stable while still maintaining this aspect of adventure with the talent. It's kind of a fascinating two-side
But
point.
it kind of aligns if you think about it, right? Like we can look at any sector, right? If you were to go into the special forces in the military, the best soldiers tend to end up in the special forces, and it's the hardest, the most grueling way to get through it, right? They get to go on the most exciting missions. When you think about your team, you're building a team of people who are willing to take on these challenges and work on them. And then you find other people with complementary skill sets that you need also on your team to do that, who have the same mission. And all of a sudden you're looking, at the team and the other people at the table in your organization, and you have people in their different roles who are all incredibly hardworking, incredibly focused, incredibly disciplined in executing, and it actually creates like a sum that is greater than its parts. And then what happens is you end up being able to be more disciplined on how you deploy capital, because you maybe don't need as big of a team because they're all working, at like superhuman efforts. And that becomes something that makes it a little bit easier when you're raising money. You can raise money and investors see that. They want to invest in teams that are world-class, that work really hard and really efficiently.
Mm-hmm.
And so it becomes this like compounding, formula for, execution, for both speed and excellence.
Mm-hmm. If you're going to build that and get it to a point where it is compounding, that obviously has to start from day one with your hiring. So how do you make sure that you're finding that in the very early team?
I think my role is always to define the problem that we're trying to solve very clearly, right? And then find people who agree that that's the problem and they want to help do it, and that people that have the skill to do it, but also the desire to build out the enterprise and build that culture, right? It comes from the top, but every layer needs to be people who want to, make a huge impact, but build culture on their teams that are places that they would want to work. That's the one thing I think, when you're an entrepreneur, you can build the place that you always wanted to work. You can, when you have that common interest, that common bond with your colleagues, it's not work,
Exactly.
It's you're building stuff. You're building solutions that can really change the way the world operates, the way we consume power. What we're doing is complementary to a lot of other companies in the energy stack, right? Like, we need more generation. We need more nuclear. Nuclear does really well with flexible storage at the point of consumption, because nuclear is a great baseload. If you can create more flexibility, you can have a higher baseload, capture that. It's all balancing, right? The supply side and the consumption side, the demand side of the grid. And there are people who are incredibly smart, incredibly hardworking, and you get those people in a room, and the outcomes can be profound.
Mm-hmm. I also think it's underrated that people, when you're structuring the culture of the team at the beginning, if you get it right, there's more than just a compounding effect of more efficient team that can deliver outcomes with less money, but also the people who are truly obsessed about these things, or who are really interested in hard problems and become obsessed about this problem in particular, it becomes a sort of community that has this magnetism that brings in other people to it. And these are the kind of people who, they would love to sleep at the office. Like they just love working on this problem, and they love being surrounded by other people who care about it. Right. And that's what mission alignment is. And people want to say it's all about these things like, oh, we've got a ping pong table, we've got these things. That's not what culture is. That's not what makes people motivated to come to the office.
Yeah.
What makes them motivated is they don't hate their life at work versus when they're at home. They have this kind of unity between the two.
Well, you that's exactly right, right? The culture is not free beer and ping pong tables. The culture is, I love working on this problem. I can't wait to solve this problem. I've got unbelievable colleagues that I love working with, solving this problem with, and I don't want to go home from work. And we have to say, yeah, guys, you have to go home.
Exactly.
It's a holiday. And the other thing that happens is people don't bring you problems. They really bring you solutions. It's like, hey, last night I was working on this and I realized we had a problem. And so I did this and this and this, and here's the solution. It's like, wow, now we have some new IP. Like, it is a totally different environment, and it's amazing to see it work.
It also requires a paradigm shift, I think, for any of the hiring managers. And this is not just for founders, right? This is anybody who is hiring in their team, is to not view this relationship as one of like, oh, I'm the manager, I'm going to tell you what to do, I'm going to give you directions. It's more of, we're literally all on this boat rowing in the same direction. And that means there's no position for somebody to stand up there and just point and whistle, right? It's everybody has to be grabbing the oars and getting moving and just pulling the company forward because they want to.
I think that's true. It's not supposed to be easy, you
Mhm.
know? I think there's too many people really believe that, like, they're looking for, they're prioritizing work-life balance. And it's not that you shouldn't have work-life balance. I think the reason that people focus on that is because a lot of them are in jobs that make them unhappy. And I think the key is, if you find, people say this, and I think a lot of people roll their eyes when they hear it, but when it doesn't have to be, I'm a musician to like love my job. You can be really curious and, building and developing solutions to problems that exist in the physical world. And it's the journey also, right? Like, you can't experience the satisfaction of crossing that finish line and with a really successful outcome if you didn't put the work in to get there. There's no context for what it's supposed to feel like if you don't learn what it feels like to do the reps in the beginning and make it happen. Do you know what I'm saying?
Yeah,
Like,
exactly. I think a lot of talent, I shouldn't say a lot, but there is probably the majority of people tend to miss the point. They see the trophy, they see the outcomes, they see these big companies who are doing incredible things, and they really like that outcome. They like to see what that life is like, but they spend so little time understanding what it was like before they got to that point, before they had their recognition, and just like the grueling nature of the race, right? To use that analogy, right?
everybody, we don't have, it doesn't take a long time to find some successful founder or some Super Bowl winning coach or MVP, Michael Jordan, to say, later in their career, what do you miss? I miss the two-a-days before the season started. Like, I miss the practices with the team. I miss the workout. Like, the things that they miss the most is the hard work with the team.
Mm-hmm. Yeah, because they really like the journey, right? And this is the hard part, I think, for
Because they
young
like the
people.
journey, because it
Yeah,
was the journey, right? It's playing the games, it's looking at those people, and saying, like, how are we going to figure this out?
exactly.
And then figuring it out when
Mm,
you're under the most, stressful circumstances.
yeah, exactly.
And it's not, and this isn't to say, like, hey, everyone needs to go out and they need to torture themselves. But I think what I'm trying to articulate is that, it takes real hard work and real output and real brain power and focus, and there's a process, right? There's some iteration along the way to, do these things.
Exactly. Yeah. With a little bit of time that we have left, I'd like to cover what actually back up to a little bit something you mentioned. So you mentioned earlier that a lot of people are proponents of nuclear and they say, "Oh, nuclear is the real way to solve things." But they assume that if you can get nuclear, you're not going to need batteries. Can you talk about how that's incorrect and elaborate a little bit on what you said about how the batteries compare very well with baseload power?
So
Cool.
when we think about our electrical infrastructure in the United States, we've got about a terawatt worth of generation capacity. At any given point, like what I said earlier, we've got all this power reserved for these peak loads. At any given point, we're normally using about 40% of that capacity. We talk a lot about generation. We do need more generation, but if you create flexibility at the point of demand and you start to flatten load curves, you can turn on that capacity, that generation capacity, all the time. Essentially doubling the amount of output that we have. But when we think about, to go back now to talk about the nuclear question, you have a fundamental truth about the grid and the way we consume electricity. It's generated, it's transmitted, and it's consumed in real time. But there's a variable load to how we consume energy. And with renewables, there's a variable load to how we produce energy, right? There's variability on both ends. So the way to manage that is with flexibility. Nuclear is a great base load, right? But you turn it on and it produces the same amount of energy. And so it's not great to have this excess energy going through the grid if we're not consuming it. So nuclear is generally, capped somewhere in that base load stack, right? With the amount of nuclear we have. We can increase that, but if you want to increase that, then you want to have some sort of off taker of that power on the demand side. So batteries is a great case for that, right? They can take that power when it's being produced and then deploy it as it's needed, as that variable load does it. So effectively allowing you to increase some of the levels of nuclear that you might want to produce. But the same thing happens with all energy. If we're able to turn on those peaker plants, use the wind and solar and just to balance there and take that power, you start to have that flexibility, at that last mile of distribution. So I think one of the things that we're going to see over the next, 10 to 20 years is batteries really becoming ubiquitous in the built environment, in cities, in suburban, urban areas. So much so that the data and that flexibility, that control really creates this proactive, energy generation set that is incredibly reliable and supports everything that we need to do and beyond. And we're going to end up with a really highly efficient.
Yeah. I think this also goes right in line with, I know I kind of want to wrap up with macro trends in the future here. So this works well. We saw Trump come into office and kind of really want to shut down a lot of things that had to do with clean tech. And obviously batteries is a huge association with clean tech. And there's all these like negative things, even when they kind of stripped back the IRA to OB cubed or whatever they call it. There was still a lot of things maintained with the battery side of things and the minerals aspect. They would just adjust it a little bit. And they even actually had a new grant for new critical minerals, which again is mostly in relation to batteries. And then recently we just saw this announcement that Mitrochem is getting, I think, $300 million in kind of combination with the US and Japan to continue building up batteries. And it's just very fascinating that even though we've got this Secretary of Energy who's really big into kind of baseload power, traditional power, that they still recognize the need for batteries. I don't know if it's from them, it's from the perspective of actually like energy side of things, or if it has to do with drones and warfare. But it is fascinating to see that we're seeing all this come around where, the pro-nuclear people are still pro battery, if you will.
Batteries are, energy agnostic, right? Like they and flexibility is really critical. And so if you want to build a resilient infrastructure and you want to produce more power, then having batteries, built into the grid, large containers, sites, demand side, in buildings, like all of that works together. And batteries are, it's an unbelievably efficient way to store and deploy power. And so it makes sense to me. I think what's happened is that batteries sort of became, it was like, almost like it was like the ugly stepsister to, I don't know if I'm supposed to say that, but like, it was basically like, this like ancillary addition to solar, right? It help make solar a little bit better. And now the real value proposition isn't necessarily into solar, and it doesn't next to the solar. It's the whole energy infrastructure it's a force multiplier for the entire system.
Yeah, just having flexibility broadly is going to benefit anybody and anything, regardless of where the power is coming from. Yeah, I think that's accurate. So we're running past on time here, so let's wrap it up with this. What do you see? Are there any particular technology that you see as batteries become especially more ubiquitous in the urban infrastructure side of things in buildings? Are there any other technologies that you see coming alongside this, or gaps that will be filled in the future that will kind of go in and partner with?
I think one of the things that we're going to see is when you start bringing intelligent infrastructure and storage into buildings, distributed throughout buildings, you're going to see a lot more innovation in energy generation within those environments. Because now you can capture that energy, you can utilize that energy, and you're going to see a much more quick adoption into technologies that will be what I would call, autonomous building, systems. You start to be able.
So the actual the actual users of power, those technologies will become,
Yeah, and
updated.
the
There'll be new
integration
innovation there.
into the
Is that correct?
infrastructure, right? If you have the stored power, you've got the intelligent infrastructure, you'll see a lot of the function happening on an automated basis. Like, it goes from everything from security to, lighting controls. There's no reason that the entire infrastructure can't recognize. We already see it in buildings where they have facial recognition for security, but a step beyond that is understanding, like, that this person at this point is going to go to this building and do and to this floor and start setting those things up. The lights turning on right before they arrive, things turning on, an entire infrastructure of the way the building works to make the convenience of the function of those people in there really smooth and seamless and efficient, because it'll know when, to do certain things based on occupancy, and it'll be much more auto.
Yeah, that's a fascinating future. I like that. I appreciate you sharing that. I always love these kind of futuristic things where everything just kind of is almost like a living, breathing organism that you can just, as a human, you get to be part of and be, go through, instead of it just being this
Well, it's
experience
kind of
where
like
you have to act
your
on it.
when you're a little kid, the refrigerator. Like, you never see the refrigerator without the light on, and so it's like it's always on, and so you don't really, that it's not, but like you've never seen it not on. And so that's sort of how I think that's a place where I think we can get to with, I think some of the real inefficiency that we see, especially in urban areas, is how street lamps work and why are they on if there's no people on the street. But why can't they get, why, there's just a lot of legacy infrastructure that is set to timers instead of intelligent controls.
Yeah, it'd be really fascinating to see. So let's wrap up with this. What are you, I guess, most excited for in the next 12 months for you at Novele?
I think for me and for Novele, it's really to see the first real scalable rollout and adoption of our products in the market, and to start, scaling the team. I think in a year from now, Novele will be a much bigger team with a significant more installations. Will probably be, well north of, 10 megawatts of installations at the end of 2026. And, it's just really the beginning of this intelligent energy infrastructure that we're going to be deploying.
Amazing. I love to see you guys leading this. This is really fascinating. I'm excited to be able to watch this journey and be alongside you guys. Thanks for coming on so much, man. We'll have to check in maybe a year or so and see where things stand.
Enjoyed the conversation.
All right, everybody, that's it for today. If you found value in this, share this episode with at least one other person who would like it. This is the best way for us to grow, is through you sharing. It's really, really the only way people can discover the podcast. The algorithms help a little bit here and there, but mostly it's through you sharing the show with other people. Finally, if you do need help winning grant funding, reach out to our sponsor, Climate Finance Solutions, at climatefinancesolutions.com. And if you want to build a truly differentiated talent attraction system, one that'll give you an unfair advantage over your competition, reach out to me today to learn how my firm EarthSearch can help you do that. That's earthsearch.com, ERTH search.com. Search is spelled correctly. So, all right, thank you guys so much for tuning in. We'll see you next time on Clean Techies.